All right, so this is the Microscale acid-base titration lab. Hopefully you've already watched the lab video of my son and I doing it. And you've got your reference table and either this lab or a scrap sheet of paper to do some calculations. You don't actually need this lab printed out. Calculator, pen, pencil. So you might have heard me mention this is called a microscale lab, which means small scale. And the benefit to doing that small scale is there's less materials used and there's less waste product produced, which is always good because we just want to get the idea and not have a lot of waste we have to figure out what to do with. So again, if you've got your reference table, this is reference table T. You'll see this formula here. This is the titration formula. Molarity of the acid times volume of the acid equals molarity of the base times volume of the base. And we are solving for molarity of the acid. It's just vinegar. And I bought that vinegar at the store, and I didn't know what the concentration was. We know the volume of the acid used because we counted the number of drops, and we know the number of base drops because we counted those too, and we knew the base molarity because it was calculated for us when I made it. So that was sodium hydroxide. And we're going to need to maybe know those formulas. They're on reference table K for acids and L for bases. Equipment, as you saw in the lab, we were wearing our safety goggles. We had a 250 milliliter Erlenmeyer flask. We had a graduated cylinder. We had the unknown concentration of, oh look, here it is. This is acetic acid. This is the vinegar. Okay, and then we've got 0.50 molar sodium hydroxide. So we still need that formula. I'll just give it to you. It's NaOH. Now, phenolphthalein is the indicator. It started off colorless, and then as we add colorless and acid, and then as we added base to it, it turned pink. And in the last trial, we added it to the base, so it started pink, and then it turned colorless. We did not use distilled water, as you saw. We were at home, so we used the tap water from the sink and then the pH paper to identify acid base. So you will watch the video. If not, you should go back and you see me do the procedure with my son. And we did have a quick shot of the data table, but of course I will help you if you didn't see it. So we tested the pH of the vinegar. Solution A is the acid, that's vinegar. And the pH of that was a 2, which should make sense that acids have low pH. And the pH of the base, which was sodium hydroxide, was a 12, which should make sense. It's a high pH value for bases. On the side of the container, it told you that the molarity of the base was 0.50 molar. Okay, so in trial 1, we started off putting 10 drops of acid in the flask. That is our volume. So 10 drops is the volume. And remember, I don't know the concentration of the acid, so that's my variable. I'm going to call it MA. If you want to call it X, that's fine too. And then we added water to give it a little bit more volume, and we added phenolphthalein, and phenolphthalein was colorless. And then we dropped, counted the base, and then we noticed that it turned pink and stayed pink at 13 drops of base. And why did it stay pink? It's because we reached the end point, which is that equivalent acid base amount. Sorry, I just wanted to get my equal signs all in orange. Here we go. I kind of like my colors. And now I got them. Anyways, all right, thanks for your patience. So the molarity of the base was 0.50. So that goes here. And the volume of the base is 13 drops. Now, normally we would probably use milliliters, but we did it drop-wise, so the units would be drops. Okay, so now we need to do our math. So this is just 10 times x equals this product. So 13 times 0.50. This is 6.5. So 10, let's just call it x. 10x equals 6.5. How do I get x by myself? Divide both sides by 10. So 6.5 divided by 10. If you didn't need a calculator, awesome. If you did, hey, we've all been there. 0.65 molar. You could call it 0.7. I'm not, crazy about number of decimal places, but the molarity of the acid is a little bit stronger than the base. So it would hopefully make sense that you're going to need more base to neutralize because the acid is stronger. So 0.65. Good. All right, now in the second trial, we doubled the amount of acid. We're still trying to figure out how strong this acid is. And we're doing it 3 times because hopefully the more times you do an experiment, the better your results should be. If I had all day to do this, I would have the best results. But really, I only did it 3 times. So, that's better than only once. And then, again, we did the same thing. 20 drops in the flask, 10 milliliters of water, phenolphthalein. It was colorless. Then we drop, added base until it stayed pink, and that was 31 drops. So again, the molarity of the base did not change. So it's 0.50, okay? And the number of drops was 31. So let's go ahead and do our math. So 0.5 times 31 is 15.5. And that's going to equal 20 times x, or the MA. Get rid of the 20 by dividing both sides. So 15.5 divided by 20 is, now this is 3 decimal places, 0.775. I think I'm going to call it 0.78 molar. You will notice there's a difference here. It's not the same. Should be the same. It's not, though. That's okay, because there's human error. There's lots of different ways that we could have those discrepancies. Okay, so in the third trial, we started with base, and we added phenolphthalein to 20 drops of base in the water, and it started pink. Molarity is still the same. Volume was 20. And we added acid this time until it became colorless. And we had 12 drops this time. So again, we still don't know. This whole point is that we're solving for molarity of the acid. The volume was 12 drops. So half of 20 is 10. Divide both sides by 12. I'm taking a little bit of liberty with the math here, just making it fast. Hope that's okay. So we get 0.83 repeating, but we're not going to do that. We're just going to call it 0.83 molar. Okay. So those are our 3 values for our 3 trials. So then it says calculate the average molarity. Well, I don't really want to do this for you because I think you can. Remember, you add all the trials, which were 3, get a sum. Whatever that sum was, you divide it by the number of trials, which was 3 in this case. So I would go to your calculator. I would add 0.65 plus 0.78 plus 0.83, get a value, divide by 3, get an answer. And since we're doing average molarity, it's going to be whatever your answer is, capital M for molarity. Now, the questions on the page are a little different than the questions on the Google form. Please answer the questions on the Google form, not necessarily all the questions on the lab. I made a couple changes, so use the Google form. Hopefully this helped, and I'm looking forward to seeing your results.